The following program is brought to you by Element 14, the electronics community where you can connect and collaborate with top engineers from around the world. Join now at element14.com/presents.
Welcome back to the Electronics Inside, the show where we tear down toys, tools and appliances just to find out what's inside. This week I'm going to be following up on the earlier series we did on the history of data storage and going for a tape drive, but not just a tape drive, an auto changer. In particular, this is the HP StorageWorks DAT72x6. So this was at one point a very expensive piece of proper commercial grade IT hardware. These days it's a bit of a relic, but I think we are just going to have to stun it. Just quickly before we do, I find it really interesting that this format is obviously a 2x5.5 inch bay type size. But if you look on the bottom here, the bit that's actually got the data interface, the SCSI, ultra-wide SCSI interface, actually looks like it should fit into a 3.25 inch bay. So we'll have a look, see if that is like an off-the-shelf thing that's been sort of hacked into an autoloader. Yeah, we'll have a look. Yeah, I kind of feel like this piece is going to come off. Less confident now I've actually said that. Let's go with it, see what happens. What's the worst that can happen? It falls apart? Oh, different size torque screws on that side. Off to a flying that screw's already loose. My warranty void stick is already torn. Got some bad news, I don't think this one's going to work. I figured that there's probably going to be three types of people out there. People that are in the IT industry or have somehow been exposed and know that tape drives exist and that they're fairly common, or at least were common. I feel like they're less so these days. There's old school people that used sort of Commodore 64s and computers in the 80s that had cassette drives and tapes as storage medium. And so it's probably no big shock to hear tape drives in computing. But I guess there's probably also a class of people that's never heard of tape drives being used with computers, or tapes. Tapes in computing go right back to the beginning. I don't want to say they're the earliest form of storage, but I think I'm safe to say they're probably the earliest form of magnetic storage. I think that's reasonably safe territory. But you can go back to very early computers and you will see tape drives. Even, I think there's a clip in the original, wow, actually, no, they're spattered all over film history now I think about it. I mean, isn't the whole subject of Diamonds Are Forever trying to swap a cassette out to change the satellite telemetry data or something?
But as usual, Mr. Bond, you were absolutely right. You guessed correctly. That box contained the master satellite control tape, and you came aboard presumably hoping to substitute this for the real thing.
And also in the original Italian job, the one from the 60s, when they do the hack on the tapes, on the traffic control computers, they're all on the big proper reel-to-reel tape drives, big ones like this. And yeah, and then of course you had computing in the 80s where using a cassette tape or something similar to store your programs was reasonably common because they were a cheap, readily available medium. So to make a big distinction between those and these store data digitally, which sounds pretty obvious. Those old kinds of tapes and cassettes all store the information analog, so just like an audio track being output, which is why if you play a tape that's got a computer program, an old one anyway, through speakers, it sounds a lot like a modem dialing, kind of that horrible computer noise. That does mean that if you are looking for software today, you can sort of play it back from a mobile phone with a headphone plug-in with your legacy system, and you should get some sort of playback in it. So this format is loosely based on DAT, digital audio tapes, which came out about the beginning of the 80s as a replacement for audio cassettes. Now, a big or a standard cassette with software or programs on it would hold roughly 150 kilobytes of data. Not a lot, and that's sort of standard uncompressed before you get into anything advanced. But that's really not a lot of data. So enter digital tapes, and they start at about 500 meg in the 80s with the I think the standard was known as DDS originally. So what's going on here? It's a sticker holding it on. Yeah, digital data storage. And yeah, I think the physical cartridge cassette style was based on a DAT, digital audio tape. But of course that was great when it outpaced and outsized a hard drive. But as hard drives got bigger, you tended to want more cheap offline storage, which is what tape drives bring. How do you fit 6 tapes in here? How do you manage 6 tapes in here? Oh, it didn't take much and she's falling apart. So yes, this was the DDS, digital data storage, went through sort of 4 iterations before it became known as the DAT76. DAT 72 even, sorry. DAT 72, not 76. And that came out in 2003. Now it is so called the 72 because it held 72 gigabytes of compressed data, 36 gig natively. And that's a lot. That's the thing about tapes, is you use them for incremental backups and store them off-site, typically, or in a fireproof safe, something like that. And the data on it is your benchmark. So this autoloader could take 6 tapes. Ooh. Okay, that was kind of unexpected. There you go, standard connector on a tape drive. And you can sort of see here the size of the cassette tape that went in, and the fact that there was, I think it's 170 meters of tape on a DAT 72. And that's 3.8 millimeter tape with helical scanning, just like the Sony camcorder we looked at. So yeah, it's a high density tape, 72 gig on this tiny little thing like this, especially in 2003. That was kind of cool. So that, I think, is actually a reasonably standard 3¼ inch, albeit double height 3¼ inch drive. So I'm going to kind of put that to one side and look specifically to start with at this auto changing mechanism. Yeah, interesting that the fascia on here, it's just got that input panel and actually still got the eject button on the front. Okay, you can see here, you definitely got sort of riser controls. Oh, pulled the wrong end of that ribbon out. I'm trying not to judge things as I take them out because I don't know exactly how this is going to work. I'm trying to get all the pieces out and then look at them out together. The other thing about tape drives, because I'm sure anybody not familiar has probably said, if they're so cheap, so plentiful, so reusable, why not use those instead of hard drives? And the digital tapes had the same issues that analog tapes had, and that is random access read times, particularly read times. I mean, this device with ultra-wide SCSI was capable of 3 megabits a second. I think it's 3 megabits, not megabytes, I think. Which was not particularly blisteringly fast, especially even at the time. I mean, if you got a RAID 5 array of Raptor hard drives, it was kind of no contest. But this was slow. I mean, it would do 20 gigabytes an hour of backup, I think, was the stated figure. It's kind of that slow plugging away as data's written to the hard drive, it's reading that and writing it to a tape for long-term storage. It's not designed for quick recall. I mean, if you've got a piece of data at the end of the tape, it's got to spool the tape all the way around that 170 meters onto one spool, read that bit from the end, and then if you wanted to read something from the beginning of the tape, or even the file system, I think got to rewind that tape the whole way back round. And you know, the spools in these used to run at 10,000 RPM, so they weren't slow mechanically, but in terms of data read-write speed, you compare that to a hard disk which can tick between the tracks in a fraction of a second, or even to an SSD, which is just, there is no seek time. I mean, there is seek time, but negligibly. I have to say, and these days I have far less to do with IT hardware than I used to in previous roles and jobs and things, but I definitely feel like tape drives are less relied on these days. The speed of network traffic in and out of sites is now fast enough that having a live off-site backup is feasible more so than having to physically access tapes, especially with mass data centers, which may not be on premises anyway. Tape drives are, I think, correct me if I'm wrong, please let me know in comments and over on the Element 14 community, I think tape drives are a little bit passé now. correct me, I don't know. Okay, let's see if we can work out what's going on. So this connector here ran round from this PCB here, this connector on this PCB, to the inside of the tape drive. So that's the interconnect between the hardware from the autoloader mechanism to the drive itself, which raises some interesting questions, which I think I'm going to come back to. Okay, we've obviously got the great big motor in here. Let's get that out. Oh, so when this sheet of metal was originally screwed to the side of this giant pressing, and that rack then pushed that drawer forwards, these little steps on the front raised and lowered the tape mechanism. Oh look, there's a little light gate at the top here. There are notches across the top of this little track, and it looks like they've actually got encoding in there. So this will run at a constant speed and actually feed back data on its position rather than just in or out like an end switch. That's kind of cool. Oh, so this big thing here is actually just a solenoid. Just fires that pin out as hard as it can, and that's what releases the mechanism. Only need to fire for an instant just to release the tape. So this goes forward, grabs a tape, lifts it, drops it, based on the sliding mechanism here. Tape drive, loading mechanism. We can see that this can insert a tape or catch a tape. This can also lift out the way. What's it doing in this position? Why does this need to rotate? Okay, so we've got a huge cavity of space up here above the tape drive. This has got to get out of the way when you're loading or ejecting a tape, but I still don't understand this turntable mechanism. It has to be significant, but I just can't place what for. So what here am I missing? We know that it can take a tape from several positions, 1, 2, 3, and load it into the machine. Why do you need to spin? I'm missing a caddy, aren't I? So it makes sense because the tapes are tiny. They're about that thick. I mean, we've already said they're what, 4mm tape, or just under. They're thin, they're like a cassette tape. That is a massive gaping hole. That is way more than you would need to get a DAT72 in. So yeah, this must have held a caddy, like a big chunk of thing, which I'm gonna guess held 1, 2, 3 tapes one side and then 1, 2, 3 tapes the other. And you charge that caddy with your 6 tapes, chuck it in this machine, and that's where the rotation comes in. So you slide your caddy in here. This mechanism can raise and lower this pick and place mechanism to one of those 3 positions on the front. Grab the tape, drop it down, stick it into the cassette drive, sorry. And then once you've used all 3 of those tapes in sequence, then you can get the other 3 tapes out the other side. That makes sense. There's a caddy that I hadn't thought of. I'm gonna say that these teeth here that just protrude on the inside past the edge of this slider actually interact with the caddy, so that's your eject mechanism for the whole caddy. So when you press the eject button on the front panel here, that motor will run, sending the whole caddy out. And your last little push, just to make sure you get well and clear. So as you insert it, push that and prime that spring, and as you pull it out, you get a little bit of extra push to get it past the end of the run on that motor. That makes sense, I like that. That's a nice conclusion. So that's the loading mechanism, and it's cool, don't get me wrong, but I really feel like it's only half the story. This tape drive, which actually does the reading and writing of the tape and the spooling of it, has still got some stories to tell. And I'm almost certain this tape drive, DAT72 drive, would have been available as a standalone part, just with a fascia that plugged into that part there, because this eject button and the LEDs on the front. You wouldn't include those, every part, every trace, every board. It's cheaper to have bought an off-the-shelf product or used one of your own off-the-shelf products, because I'm pretty sure HP owned the DAT72 format, so no one else would have been producing them. Oh, it's like a mini VCR. All of a sudden having massive like PTSD flashbacks to doing the Sony camcorder. There we go. There is some proper hardware. Although I can honestly say I've never seen a ICs with heat spreaders like that. I mean, I'm assuming these are heat spreaders, but they've got like windows out of them. I don't know why that would be. Any ideas? Share with us. Let the rest of us know. Obviously this connector on the front here was the one that connected to the loading mechanism board. Oh, these sorts of mechanisms absolutely enthrall me. I can't see one and not be fascinated by it. So slide the tape in the front here. You can see how small these tapes are. 170 meters of tape go in one of these. As it gets inserted, it presses back on these, and that releases sort of the mechanical braking on the side here. There's also a little armature down here, which one of them somewhere is going to hit a micro switch, so it starts to then motor that feed. And as you press it back, preloading this spring at the back, maybe we start with the motor at the back. Anyway, yeah, tape insert, push there, motor will catch and start and finish off this route. You can see it goes back and down, and back and down, and these top bits just slide back. And as it does, also the tape feed mechanism will start. So this is probably a separate electronically actuated mechanism, which then grabs the tape at the front of the cassette and starts feeding it back, and these little pulleys you can see on their path will pull it round the read head, and it will go sort of 3/4 round, and that then spins and reads writes data from the head. Probably get a clearer view of this as we take it apart, but knowing what these mechanisms are like, it's also possible that I can't get any sort of sense of mechanism of how this is going to work until it's absolutely in pieces and I can't show it to you. So hopefully that'll make some kind of sense. You can see it much better now. So insert the tape, those arms fold in, allow this to move back to this position, at which point a micro switch will be made, and then a motor will take over and pull it all the way down. You see that probably doesn't go all the way now because I've got the motor in the way, and loads it onto these two spools. Now don't forget, the job of these little things is not actually to feed tape in and out the machine. They're just to take up the slack as the pinch roller, which is this object just here, and its nice little flat pancake motor under here, actually draw the tape through at that constant rate. The other cool thing that I really wanted to point out is this. So that'll actually clean the tape as it feeds through the machine. There we go. Right, you can see the tape loading mechanism. So imagine the tape has gone in, slid down over the spools, the front has opened up, and the tape has actually been pulled across the front of these devices just here. So if I can keep that going, sorry, I'll probably speed this up in the edit. You can see how far that tape gets drawn out of the cassette cartridge and round this helical read-write head. Not really expecting much on here. Yeah, just... Okay, so how weird. It's like a single layer surface PCB that's mounted to steel. These little spools are actually like electronically braked to provide the right torque. So I'm guessing this is gonna... Wow! Look at that! Little windings, and these must be permanent magnets. Yeah, that's crazy. So these use like motors, like regenerative braking, to control the torque that's actually being applied to the tape rather than just using springs and friction. That's the coolest thing ever. Look at the windings on that PCB. I'm always blown away by read-write heads. The fact that how fast they spin and that you can actually read-write data of high enough accuracy is just astonishing to me. But it's interesting here that with the read-write head removed, you can see that lower sort of score liner on the fixed drum. That gives you an idea of how pitched over this is, and how the tape sort of wraps around and writes stripes of data across the tape. So the point that I really wanted to make with this is that there are two power connectors. You've got a Molex connector on here, which was part of the mechanism which handled tape auto-loading. But you also had a Molex connector, but also the only data connector on here to the computer was the ultra-wide SCSI. Now, it's kind of plausible to believe that on this board had different firmware which sort of told the computer that this was an autoloader tape. I feel like it had to identify as an autoloader, so it would continue writing to it time after time. The tape drive had to then handle quite a bit of intelligence because the only interface was kind of quite a low level. I mean, it was, where's the connector on there? It's 12 pins. 12 pins are the only thing that connects the otherwise standard off-the-shelf DAT72 tape drive to the autoloader mechanism. That's this connector just here, connecting to the front there. I'm surprised. I would have expected more interface between the two. I know this has to do a lot more heavy lifting. All the mechanism has to do is run a few motors, monitor a few end switches. It doesn't really need any intelligence to it as such. All the intelligence for reading and writing the machine is still on this board. But 12 pins? I mean, I guess. I hope that you found this an interesting one. I've really enjoyed it. And I hope that this adds another little bit to the history of electronics and data storage. If there is anything else that you think we'd like to see, please head over to the Element 14 community and let me know at element14.com/the electronics inside. I'd love to hear what you'd love to see. Thank you again for watching. I'll see you next time.